Welcome to Section 2 in our journey to master the Go programming language. In the previous section, we were introduced to Go, and then we went to write a non-trivial Go application to consume a RESTful API. In this section, we will take a deeper look into Go's building blocks. Let's start. Let's begin by talking about packages, variables, and functions, which constitute the skeleton of any computer program, and dive into how to express logic in Go via conditional statements and loops. From there, we'll start discussing some special features in Go, like structs, slices, and maps. We will solidify our newly acquired knowledge by two advanced applications, a binary search algorithm and a set. Now let's begin with our first video. This is where we will cover the main building blocks that almost all programming languages share, like packages, variables, functions, and special types of variables. We will discuss pointers, type conversions, and constants. We already covered packages in the previous section, so let's do a quick refresher. Any Go code file starts by defining the package to which the file belongs. The package name of a file should be the name of the folder at which this file is located. If the package is called main, then the package becomes the entry point of your program. You can import an external package to your program by using the import keyword with the package name encased in double quotations. To import multiple packages, we use the round brackets as shown. If your package files either exist under one or more folders inside the source folder of the Go workspace, or if your package files exists in the Go standard library, then you can import it as shown. MathRand is a package in Go's standard library. Rand exists under math. To illustrate this point further, if we go inside the source folder for Go, you can see the math folder here where the math package is hosted, and then we can see the Rand folder underneath, and all the files that belong to the Rand folder also belong to the Rand package. And then when we call this package from the outside, we call it as math/Rand. Functions in Go are constructed using the func keyword. The curly open brackets must be on the same line as a function declaration. If a function name starts by an uppercase letter, we call this function exported, which means the function is visible outside this package. If we type utility.sayHello from another package, this function will be called. A function takes 0 or more arguments. We define argument names and types as shown. Notice how the type comes after the name of the argument. A function can return multiple results in Go. We define it by specifying the return types after the function name declaration. Notice how when we define the function arguments, we didn't need to define the int type twice. That is because Go will understand that A and B are of the same type. Moreover, we can define the names of the variables that will contain our return values. When using named results like these, we just need to use the keyword return with no arguments to return the current values. Bear in mind that this may hurt readability in long functions. Go supports treating functions as values. They can be contained in variables and passed around. So as covered in the previous section, the $= operator evokes Go's support for type inference, as it creates, then assigns variables via the same statement. It is important to mention that the $= only applies inside a function. Since a function could be a value, you can pass it as an argument to another function as shown, adding decent flexibility to your code, as it allows you to pass functionality around and not just values. This enables interesting design patterns in your Go code. Here is how we call the function and add the other function as an argument. We can also call the add function directly by doing this. So the add variable acts as a full function. Go also supports function closures, which would allow your function to be bound to the variables of the originator function. For example, creating an incrementer like this will allow you to always get an incremented value in your program. So if you create a variable called inc of type incrementer, you can just keep incrementing like this. And because of the function closure, the I inside the incrementer will keep getting incremented without us having to keep track of it outside of our function. Now it's time to talk about variables. In Go, there are multiple ways to declare variables. We either use a keyword var or we just use type inference with the $equal symbol. Keep in mind that the type inference with $equal only works if you are inside a function. That is because a Go keyword must always be used for code outside of functions. Hence, you will need to use the var keyword if declaring outside of a function. Go supports all types you would expect from a modern programming language. As we continue in our journey, we will be using these types to build the Hydra spaceship software. If you use int, Go will decide for you whether it's int32 or int64 based on your operating system. If a variable is declared but not assigned a value in Go, it gets a 0 value, which is either 0 for numeric types, false for Boolean types, double quotations for strings, or nil for other types, like pointers, functions, interfaces, slices, channels, and maps. We'll discuss those types in details in this course. Another type worth mentioning is arrays. To declare an array, we use square brackets as shown. The array type has to be next to the square brackets, and the number of elements must be in the declaration. In Go, you can use the len keyword to get the number of elements in the array. As in other languages, we use square brackets to access an element in an array. Arrays in Go, however, are not flexible. They have fixed sizes that can't be extended. Go provides another type called slice for more flexible data structures. Declaring a slice can be very similar to an array, except that we don't specify the number of elements. To add an element to a slice, we just use the keyword append as shown. We will talk a lot more about slices in future videos of the course. Go also supports pointers. Pointers store memory addresses for variables. You can declare a pointer by specifying the type next to an asterisk. The pointer type specifies the type of the variable for which your pointer will store the memory address. You can get the address of an existing variable by using the AND symbol. If you use an asterisk before the pointer name in your code, Go will understand that you're seeking the value of the variable that the pointer points to. This is called dereferencing. So in this case, I is an integer of value 4. Then P2 is a pointer that points to the address of I. So if you want to get i's value from the pointer, we use an asterisk with the pointer name as shown. And this will dereference the pointer to get the value of I. Now that we understand pointers, let's cover a very important use case. In Go, arguments are mostly passed by values, meaning that function arguments get copies of values instead of the variables themselves, or instead of the variable references. So for example, if we try to write a function to change the value of variable x, like this, the value of x will not be changed since what got passed to the function was a copy of x instead of x itself. If I hit run, it's still 5. But what if we want the function to change the value of x? In this case, we can use pointers. So let's change the function to take a pointer of an int as opposed to an int, and then to assign a value to where this pointer points. So we will use dereferencing to assign a value to where the x pointer points. And then when calling the function, instead of passing x, we pass the address of x by using the and symbol. So by doing this, we will pass a copy of the pointer, but it will still point to the same variable, which is x. So if we run now, our value will change. Perfect. Type conversions are straightforward in Go. They work by wrapping your variable with the conversion type. Go requires explicit conversion whenever you need to assign a variable to another variable of a different type. Constants are just declared by the const keyword. A constant declared without a type takes the type of the value assigned to it. So in this case, pi is of type float. Constants are also used in place of enum in the Go language. In this video, we had a deeper look at packages and functions in the Go language, with its flexible features, and explored variables with their types and pointers at the end.